if we move down a bit, we can see that the next thing to define is the screen coordinate origin. And if I go back to our picture here, then the screen coordinate origin is where the camera plane, so center of come back down here and open that bit up. The view plus length, that and there. So now we want to calculate where the image vector, and the way we do that is we open this bit here. So let's take a point on the image, on the object being photographed. So we'll take a general point x, y, and z, and we're going to write down the parametric equation of the line connecting the viewpoint to that point using this. And well, the way we find the value of the parameter t is that we require that this point here be in the image plane. So in other words, we get an equation for t by taking the difference, or computing the vector connecting the this point here to the origin of the screen coordinates, and then taking the scalar product of that with the camera axis vector, and that should be 0 because we want this vector to be in the plane of the screen and this vector to be perpendicular to it. So we compute that, and that gives me this equation, and you can see that it only involves linear values of t, so we can set that equal to 0 and solve that for t, and that will give us this expression for t here, and then we can use that to find the coordinates of the point in the screen plane using this. So that's that. It seems to be taking some time, but it works it out. So it's quite a complicated formula, but on the other hand, it's a formula. So now what we want to do is to now calculate the screen coordinates, which are well, let's see what they are. The screen coordinates will be a two-dimensional vector in the screen plane, and it will be the components of this vector relative to the screen origin, and then the scalar product of those with the unit vectors for the horizontal and vertical screen axis vectors. So let's do that. And there we are. Again, even more complicated formulas, but they can be calculated. So we've now got all our cannons in position, or our guns in position. So now let's turn our attention to the image. Well, I can define 4 points at the vertices of a tetrahedron using this, and I'm now going to use a piece of graphics code very similar to the first bit to get Mathematica to use the three-dimensional primitives in Mathematica to calculate and visualize that scene here. So this is Mathematica has chosen a viewpoint, and you can see quite clearly that this is some kind of pyramid. And what we're going to do next is to recalculate that image using or from what we've done in the previous section. So let's stop there.